Okay, this is example 1 on page 4 of slides 5-3. So here we are to maximize the function fxy, which is 120x minus 4 times of x squared plus 2xy, or also 2yx minus 3y squared plus 96y minus 102. And here, subject to is abbreviated into ST, x plus 3y smaller equals to 96. Okay, here we can note underneath the optimization argument, which is the max here, the independent variable, namely the choice variables. Okay, just to remind yourself, what are the variables that you need to work on? And this is the constraint. So let's remind, what are we supposed to do? So here it is the optimization problem, but there is a constraint, right? This is different from the previous unconstrained optimization. So here, in order to solve this optimization, what we need to do is to set up the Lagrangian equation, which is L equals to fxy, which is the function itself, plus lambda by constraint equal to 0. So maybe you're confused about what this means. So actually it is that we are approached to the limit of the constraint, which is x plus 3y equals to 96. And here, if we were to take a step further, we can move x plus 3y to the other side of the equation. So we have 96 minus x minus 3y equal to 0. So that is the constraint. So that is exactly what constraint equal to 0 means. So here, what we are going to do is we set this up. So now we can make this general expression more accurate, which is, in this case, 120x minus 4x squared plus 2xy minus 3y squared plus 96y minus 102. That is fxy, plus lambda multiplied by the constraint, which is 69 minus x minus 3y. Okay, so later on, I will let you know why do I prefer to have the number first and have the variables to follow as deductions. Okay, so here we have the Lagrangian, and in the Lagrangian, you should be reminded that the original two independent variables still are the independent variables. And here we introduce a new variable called lambda. Okay, so that means later on, it is actually similar to the first order condition of unconstrained optimization. Here later on, we're gonna derive the first order conditions. So that is partial derivative with respect to x of the Lagrangian equation, partial derivative with respect to y of the Lagrangian equation, and the partial derivative with respect to lambda of the Lagrangian equation. Okay, so possibly you were asking, you bear this in mind, why do we have to add this lambda multiplied by constraint equal to 0? Here is why. So if you were to take the partial derivative in this case with respect to lambda, the entire fxy has nothing to do with lambda, so you can disregard. You can consider them as constant. The derivative of them is 0. Then for the last term, it is lambda by 96 minus x minus 3y. Also, it can be rewritten into, say, 96 minus x minus 3y by lambda. Okay, so what does this mean? This is to say the entire thing, 96 minus x minus 3y, which is constraint, is a constant multiplier to lambda. So the partial derivative, then, it is just the coefficient, the slope term of this linear form of lambda, right? So that's the first order derivative, and equal to 0. The entire thing constitutes the first order condition for lambda. So here you see, why do we introduce lambda multiplied by constraint equal to 0? Because we want to ensure that this constraint is met, is satisfied. So that's the skillful thing that Lagrange has created. Okay, so then let's look at the derivatives. So the first one, partial derivative with respect to x. Okay, the first term is 120 minus 4 by 2x. And here, 2xy, that can be also rewritten as 2yx, right? In this case, 2y is the entire thing. 2 multiplied by y is the constant multiplier. And as you're taking derivative with respect to x, y is also considered as a constant. So the derivative with respect to x of 2yx is 2y. 96y has nothing to do with x. Minus 102 is a constant, has nothing to do with x. And then for this term, there is something to do with x. So if you want to make it more straightforward, you can expand, factor out this multiplication. So you have 96 lambda minus lambda by x minus 3 lambda y. Okay, so here we do have one term that has something to do with x, and the derivative of that is minus lambda equal to 0. Okay, so here we can further simplify this. We have 120 minus 8x plus 2y equal to lambda. We can move lambda to the other side and change the sign into positive. So that is equation 1, comes from the first order condition. Okay, and then let's do the first order condition with respect to y. The first two terms has nothing to do with y, so disregard, they are constant, right? The third term, 2xy, the derivative of that is 2x minus 3 times of 2y plus 96. And it's a constant, the derivative is 0, disregard. And here, for the multiplication involving the constraint, we only have the last term that has something to do with y, and the derivative of that with respect to y is minus 3 lambda. So that equal to 0, and we rearrange this. We have 2x minus 6y plus 96 equal to 3 times of lambda. Okay, so here that is equation 2. All right, we can actually use equation 1 and equation 2 to eliminate lambda. Okay, so 1 and 2, what we have is 2x minus 6y plus 96 equals to 3 times of lambda, which is this left-hand side of the first equation, 120 minus 8x plus 2y. And we can further calculate that, 360 minus 24x plus 6y. Okay, then we can rearrange this. All right, to further simplify, we move x and y to the left-hand side and the constant to the right-hand side. So we have 2x minus 6y. Now, minus 24x, move to the left-hand side, change to positive. 6y to move to the left-hand side, change to negative, equal to 360 minus 96. The 96 was positive on the left-hand side, move to the right-hand side, change to negative. So that is 264. Okay, so now let's further simplify the left-hand side. The left-hand side is 26x, which is 2x plus 24x, minus 12y equals to 2 times 264. And here we can further simplify this by dividing 2 to both sides. We have 13x minus 6y equals to 132. Okay, so that is equation 4. And here, equation 3, we can make it easier by moving x to the other side. X equals to 69 minus 3y. Okay, so x equals to 69 minus 3y, and we can take this into number 4. So 3 into 4 to eliminate x. So we have 13 multiplied by 96 minus 3y minus 6y equal to 132. And here we can further calculate the result and get y. So here it is 13 by 96 minus 39y minus 6y equals to 132. And here we can refer to the calculator to find what is the result of 96 by 13. That is 897, okay, minus 132. We move 132 to the left-hand side and change the sign into negative, equal to 39 plus 6. 39y plus 6y, which is 45y. So y star, in this case, equal to the left-hand side is 765 over 45. Which is 17. And then we can take, we name this as 5. We take 5 into 3 to find x. So x equal to 96 minus 3 times of 17, which is 96 minus 54. Sorry, 51. The result is 18. So when x equal to 18, y equal to 17, the function is optimized. So here is the result for this, okay? And then you can take this into here, into the first one, to work out lambda. So here, lambda star equal to 120 minus 8x star plus 2y star, which is 120 minus 8 by 18 plus 2 by 17, which is 10. Okay. So let's verify this. 8 by 18. Yes, the result is 10. So here, last thing that I would like to let you know is what this lambda means. Okay, so previously you saw the function of lambda, that is to make sure that this optimization is subject to this constraint. Because with lambda by constraint equal to 0, this term introduced later on as we are solving for the first order condition, we can ensure this constraint is just met. And here we have a further interpretation of lambda. It tells you if this constraint is loosened by 1 unit. Say if, so previously we only give you 96 units to be distributed to the summation of x and 3y. Say if we change 96 into 70, that's increased your limit by 1 unit, right? How the objective function, the value of the objective function will change. How much will that change? The result is 10 units. So if I give you 70 instead of 69, now the function, the optimized value of this objective function is estimated to increase by 10 units. So that's how to interpret this lambda, this multiplier. Let me write it down here. So lambda equal to 10 tells you if raising the constraint by 1 unit, which is from 96 to 70, the optimized value of the function under this new constraint is estimated to increase by 10. Okay, so that's how we interpret this lambda. We also call this shadow price. Okay, so basically, if you were to loosen this constraint, if you allocate more resources to the combination of x and y, right, then how the target, how the objective function can possibly increase.